Hey everyone, I hope everybody's doing well. It's been a little while since I made a video since last week, so I'm excited to make a nice quick short video here for you. I just want to take a few seconds to have you take a few notes on the next form of energy. The next form of energy is a really interesting type of energy. It's magnetism. And magnetism, kind of in my opinion, is one of those types of energy that we don't know a ton about, or we know things about it, but we just don't quite fully grasp why it is there and what it's there. It's just one of those kind of natural wonders that we have. And so let's start with the definition. The definition for a magnet is an object that attracts a ferromagnet element. Okay, and so I just want you to write that down. Basically, it is any element that has some sort of a magnetic attraction. Okay. And then please include some examples with that. So some examples that are typical that we use most of the time are going to be iron and nickel. But one of the examples that is actually a natural example is lodestone. And that's basically when you have a piece of magnetite, the element magnetite, and it is become magnetized because of the Earth's magnetic field. And so I want you to include those as your examples for a magnet. But most of the time you've seen a magnet, it's probably been like the one pictured here, which is called a horseshoe magnet in that shape. Okay, or you probably have seen a bar magnet. If we were in school, we have plenty of both of the types of magnets, and we would be using them and trying them. But you could also use any type of magnet, the magnets on your refrigerator, or any magnets that you have at home to take a look at these today and see what they're all about. Okay, and so just add to that, it must have its atoms ordered properly. And when we talk about that, it means that it has a magnetic domain. Okay, which I'll explain that in a little bit more detail in a bit here. Okay, but we can use magnets from anything to just little household items to obviously much bigger things, like in these pictures here. But what are these different types of materials? So you just hopefully have these down as examples, but I just wanted to show you a picture of each of these. Okay, so you have the elements of iron and nickel, and then cobalt also is magnetic. Okay, so it's any material that is really strongly attracted to a magnet. And then you have lodestone also, and you can see lodestone. These are some staples that have stuck to it. I remember doing this in college and having some of the lodestone and just really being able to see that it just looks like a piece of rock, and then all of a sudden metal like iron or nickel will stick to it. There was even a few different types of rock that I had, different types of magnetite, that one was magnetic and the other one just looked like a rock. And the only difference between the two, even though they looked the same and had many of the same properties, was that one was magnetic. And that's the only way to distinguish between the two. Another vocabulary, I want you to write down a magnetic pole. Magnetic pole is the place on a magnet where the force it applies is the strongest. Okay, so just like on Earth, in a magnet, there's two poles. There's the North Pole and the South Pole. And I'm sure at some point in your life you've played around with magnets and you went to stick two magnets together and they either attracted and stuck together, okay, and then you had a hard time pulling apart, or they repelled. And when you put them closer together, they seemed like there was this little magical, the way I can describe it, or energy force between repelling these or pushing them apart, not allowing for you to stick the magnets together. And so how does that work? Well, if you think of the opposite ends, so if you have a magnet, you have the north pole and the south of the magnetic pole, they're going to stick together. So whenever you have those magnets that will be sticking together, you have the north and the south connecting. Whenever you feel that repulsion, that repelling, it's going to be either the two norths or the two souths towards each other. And so moving on here, another vocabulary is that feeling that you have where they're either pulled together or being repelled apart is what we call that magnetic force. Okay, and because that either repels or attracts, we as humans have found many different ways to use magnets and use that force in between, that either the attraction or the repulsion. Okay, and so I'll give you some examples on how we use that, and you use them every single day in your life, most likely here. Okay, and so magnetic fields, it surrounded every atom that makes up all materials, but not all materials are magnetic. So within everything there is this magnetic field. However, not everything has a strong magnetic field with it. They are created by atoms constantly moving electrons, just like with electricity, when you had the electrons moving into a circuit. Very similar as far as magnets as having the electrons constantly moving. And then they determine whether a material is magnetic or is not magnetic. And one of the things I find most interesting, and like I said, is not something that we fully grasp, but our Earth just has a magnetic field that has just naturally been here, okay, since the time that we know of it. Uh, we have this magnetic field that surrounds all these different atoms of things that we have on Earth or in the universe. We have it with our whole Earth. And what I find interesting is that the North Pole and the South Pole of our Earth, okay, actually aren't exactly what our magnetic north and magnetic south pole are. So if you look at this map right here, this is the geographical North Pole, like where you would say this is the North Pole where the stake is, and you go to the very top point of the Earth. However, the North Magnetic Pole is actually here. It's down a little bit, okay? Meaning that if you were using a compass and you were to go past this point, it would then switch and be the exact opposite. And you can see from these images here too, with the pole of the force that our Earth has, where we have the North and the South Pole, and we have the attraction and that force between it that just naturally occurs within the Earth. And why might that be? Well, one of the main reasons is because the core of the Earth, the center of the Earth, is made up of mainly iron and nickel. And as we learned earlier, iron and nickel are some of the most attractive elements to magnets. And so therefore because we have that the iron and nickel core, we have kind of a natural magnetic field on our Earth. And so here's what I'd like for you to do. I'm going to share these slides with you. You're able to look over them a little bit more. I want you to click some of these links. Especially this one. This one talks a lot about what magnets are used for. And one thing that I have found interesting is that in a lot of the different motors and electronics and things that we use magnets to help drive those things, either for storage of things, or if you think of a simple motor that was in any of your like toys when you're growing up here, like the little toy car and things. There's going to be, if you've ever taken those apart like I have when trying to build things and put things back together, you'll see that there's usually this wire and then there's a magnet around it. And basically what's happening is that wire is moving because of the north and south pole attraction of the magnet that's within the motor, and allowing that motor to spin, giving you electrical, transforming that to electrical energy, and then allowing for you to drive whatever it is. Okay, again, we have some of these at school, and so sometime if you would ever want me to show you, I sure can. I know some of you saw me playing around with it a little bit with a solar energy motor that's just like that. That I had in the back of my room. And then there's also some things, if you do not have any magnets at home and you're not able to see this firsthand, there's some online magnets that will show you how this repulsion and attraction works between magnets. And then also there's a couple of cool videos if you have some time to watch a little bit of these videos to understand a little bit more about magnets and how they use. Magnets are much more detailed thing than what I'm giving you. I'm just kind of giving you the overview of it. So if you want to learn more about them, there is much more. But this is the next form of energy. The next form that we'll do on Thursday is sound energy. So your only assignment really today is to just look over these terms, take some notes, and then just play around with magnets if you can a little bit to try to understand how that force works and how we might use that as far as energy goes. If everybody's staying well, please continue to do your work. We have just 2.5 weeks now left, and then into summertime officially. So take care, everyone. Thank you for listening.